Okay, so we're going to dive into something really cool today. A whole new way to think about memory. We're going to look at how your brain takes all the just chaos of your daily life and somehow makes sense of it all. It's a model called the Brain Kinematics Model, and it's all built around this one fascinating idea: hippocampal curve fitting.
I mean, just think about your day so far, right? It's a total mess of sights, sounds, feelings, just all these scattered little data points. So how on earth does your brain take all of that raw data and turn it into one single clear memory? You know, something simple like, oh yeah, I had a great coffee with a friend this morning.
Well, the answer, according to this model, is actually surprisingly elegant. It turns out your brain is basically acting like a data scientist. It's using this really powerful trick to find the story hidden inside all that static. And that process, it's called curve fitting.
Okay, so before we get into all the brain science, and we will, I promise, let's just make sure we're all on the same page with this core idea. It's all about finding the signal in the noise. And honestly, the concept itself is super simple. Just picture a graph with a bunch of scattered dots all over it. Okay, that's step one. Now, step two, your job is to just kind of squint at it and see if you can spot the underlying trend, the pattern connecting them. And then finally, for step three, you just draw one single clean line, a curve, that best represents all that messy data. And boom, that's it. You've just fitted a curve. You've found the signal hidden in all that noise.
All right, so now let's take that simple idea and connect it back to your brain. Because it turns out you have this incredibly sophisticated biological curve-fitting machine running inside your head. Like right now.
In that machine, it's the hippocampus. Yeah, that little seahorse-shaped structure deep inside your brain. In this model, that's exactly what it's doing. It's acting as a biological curve fitter. It takes all those scattered dots from your senses and draws them together into one single coherent memory curve.
So you might be wondering, how does it actually do that? Well, let's pop the hood on this thing. We're going to take a quick tour of what you can think of as the memory assembly line. Okay, fair warning, we're going to get a little technical for a second here, but stick with me. The best way to think about it is like a four-station assembly line. First up, the dentate gyrus comes in and separates all the inputs. Then, station 2, a part called CA3, starts to complete the pattern. Next, CA1 does a quality check. It checks the fit. And finally, the subiculum packages it up and exports the final memory curve. Don't get hung up on the names, seriously. It's the jobs they do that's important.
Right, so let's give each station a job title. The dentate gyrus, or DG, think of it as the bouncer at the door. Its job is to make sure similar memories don't all blur together. Then you've got CA3, the storyteller. This part is amazing. It fills in the blanks when you only have a partial cue. Next is CA1, the fact checker. It compares this new memory to everything you already know just to see how it fits. And finally, the subiculum. That's the shipping department. It formats the finished memory so it can be sent off for long-term storage.
But here's the twist. And honestly, this is where it gets really fascinating. This whole system, it's not designed to be perfect, not even close. In fact, all of its real power comes from the fact that it creates beautifully imperfect memories. And look, the source material for this model just puts it perfectly. It says, the fitted curve is never perfect. Imperfection is thus structurally built into hippocampal memory processes. Think about that for a second. It's not a bug, it's a feature. It's supposed to be that way.
So this completely forces us to rethink what memory even is, you know? Most of us walk around with this idea of the perfect fit myth, that our memory is like a flawless video camera just recording everything. But the reality is the imperfect fit. Our memory is a best fit approximation of what happened. It's the summary, not the word-for-word transcript.
And this one single idea, this idea of imperfection, it explains so much about the human mind. It's like two sides of the same coin. On one side, yeah, it's responsible for the flaws, things like false memories, mixing up details. But on the other side, it is the very engine of our greatest strengths, our creativity, our imagination, our ability to dream up brand new ideas.
So what happens next? After the hippocampus creates this best fit curve, where does it go? Let's follow that signal from the curve all the way up to consciousness.
Okay, so that finished curve gets exported from the hippocampus and it's sent back out to the cortex, the big, wrinkly part of the brain. And that's where it helps build our stable, long-term memories. It gets woven into the fabric of our higher-level thinking, our reasoning, our planning, the whole shebang. Now, for any of you out there who are already familiar with a bit of neuroscience, I want to be clear, this isn't just some cutesy analogy. The terms in this model translate directly to established scientific concepts. So what we've been calling curve fitting this whole time, that maps directly onto what neuroscientists call pattern separation, completion, and comparison. So we're not trying to replace the science here, this is just a really powerful new language to describe what's happening.
So, what's the end result of all of this? Well, picture your brain just constantly, frantically, creating and comparing dozens of these memory curves all the time. But to actually guide your actions, it has to choose one. It can't run on all of them at once. And ultimately, only one stable, high-ranking curve can emerge at any given moment. That single winning story, that's what becomes your conscious focus. It's the very basis for your goals, your decisions, and maybe even the narrative you tell yourself about who you are.
And that kind of leaves us with a pretty profound question to chew on, doesn't it? If your memory, your very identity, is just a best fit curve and not some perfect objective recording, what does that say about the stories you tell yourself about your own life?